Okay, so now that we know how to read the t-distribution, now what we're going to do is we're going to take a look at some of the properties of the t-distribution, being able to find the t-critical in the chart, and then also applying it to a confidence interval of one mean where the population standard deviation is unknown. Alright, so the problems from before and these problems look very, very close to one another. The only difference between them is that the problem will specifically say that the population standard deviation is unknown. All right, so this is extremely important to determining which formula to utilize or not utilize. Okay, so if the population standard deviation is unknown, right away you know that you have to use the t-distribution. Okay, if it is known, then you use the z-distribution. Okay, now I'm going to show you how to compute the t-critical values. Okay, so I want you to have that chart out that we just discussed, the t-critical value. And I want to make sure you can all read that. Okay, so one of the first things we want to do is make sure that we can construct, or we can look at the t-distribution. So for letter A, it says that we have degrees of freedom is 11 and the confidence level is 99. Okay, so if at t-critical we have degrees of freedom is 11 and the confidence level is 99%. Okay, what you're going to do is you're going to go into the table and you're going to look this up. Okay, so for 99%, you're going to go to the very bottom of the chart and you're going to go to the far right column at 99%, and you're going to trace it all the way up to 11 degrees of freedom. The value that I get from that is going to be 3.106. Okay, so take a moment, make sure you can find that. Okay, important that you can find it. For letter B, this time t critical. Now the n is 23, which means that the degrees of freedom are 22. Okay, so remember, degrees of freedom is always given by the formula n minus 1. The confidence level is 95%. So you're going to go to the chart, you're going to go to the middle column, okay, because if you look at the bottom, 95% is in the middle and the bottom. You're going to go up to 22 degrees of freedom and verify for yourself that 2.074 is the correct value. Okay. For letter C, t-critical is going to be given by degrees of freedom, which is going to be 195, that's n minus 1, and then 90% is the confidence level. Now, you go to 90%, which is the second column from the left, and you're going to try to find 195. And unfortunately, you either have 180 or 250. Okay? Remember, what you always want to do is you want to round down. In this case, the closest value that's less than 195 is going to be 180. Right? So you're going to go to 90%, you're going to go to 180, and I got 1.653. Okay. So make sure that you can read the t-critical chart or the t-distribution. Okay. Pause the video now, and if you weren't able to get those three numbers, go back, look at it again, and don't continue until you can do that. Okay. All right. Now that we know this, we can go ahead and we can try to formulate, okay, or we can work a few problems that involve this. All right. Now, I'm not sure what happened, but I lost my formulas right here, but that's okay. I can go ahead and put those back in. So the formula for the margin of error, there it is. It just appeared out of nowhere. Good for us, so we don't have to look at my handwriting. All right. Notice that the formulas are fairly close to one another. So the margin of error is plus or minus t critical times s over the square root of n. And also notice that the confidence interval is going to be x bar plus or minus t critical times s over square root of n. just like we saw in the previous types of confidence intervals, I want you to notice that the margin of error is actually the large majority of the rest of the confidence interval. Okay, so and again, it just disappeared on me. I'm not sure where it went. I can bring it back. There we go. All right, so once again, margin of error is going to be the latter half of the confidence interval. All right, so to finish this section off, or this video off, what I want to do is I want to take a look at an example where we're going to put everything together. We're going to read the t-distribution. We're going to identify that it is a t problem, not a z problem, and then we're going to use the formulas. Okay, so this time we have a sample of 13 people, and our sample of 13 people, it showed that the average sleep time was about 7.3 hours. Population standard deviation is known to be normally distributed, but it's unknown, or the population distribution is known to be normally distributed. However, the population standard deviation is unknown. Okay, as soon as you see that, you know that you're dealing with a t-critical problem. Okay, so it's extremely important, as soon as you see unknown, that you are dealing with t-critical. Right. We know that the sample standard deviation was found to be 1.9 hours. Okay, so based on all of that, we want to find the margin of error at 95% confidence, and then we want to figure out what the true mean sleep time is by finding a sample, a confidence interval for that. Much like we did in the previous examples, let's go ahead and we need to identify a number of variables. So now we need x bar, we need s, not sigma, we need n, and then we're going to need t-critical. Now to get t-critical is going to be based upon the confidence level and the degrees of freedom. Okay? None of these are difficult to identify. All right. First of all, sample of 13 people. 13 people is n. Because we know that n is 13, degrees of freedom is going to be 12. Okay? So remember, degrees of freedom is always n minus 1. Average sleep time, 7.3 hours. Sample standard deviation, S, 1.9. Okay, so again, sample standard deviation was found to be 1.9. That's our S. Right? Confidence level is given as 95%. And from here, we can identify what t-critical is from going into the chart. Okay, so our t-critical for this problem, we have 12 degrees of freedom. We have a confidence level of 95%. And if we look at our chart, that should give us 2.179. Okay, so verify that for yourself. Okay, and if it doesn't work out that it is, go back and make sure you can resolve that. Okay, so we have our formulas. Okay, so we're going to use these two formulas, okay, to be able to find out what the margin of error is as well as the confidence interval. Okay, so we're going to hold on to this information. So for letter A, we know that the margin of error is going to be equal to plus or minus not z critical but t critical times s over the square root of n. We know t critical, we just found that, 2.179. We're going to multiply that by s, which is 1.9. We're going to divide that by the square root of n, which is 13. I'm going to type this into my calculator. And please do the same just to verify. I ended up with 1.148. Don't forget the plus or minus, okay, since it is a margin of error. Okay. Notice it's almost the same thing as what we did before with population standard deviation known, except now we have to go through and find t critical. Last thing we're going to do is find the confidence level or the confidence interval, and then we're going to describe it. Remember, confidence interval is going to be x bar plus or minus the margin of error. Well, remember, we found x bar all the way back up here to be 7.3. That's the mean hours of sleep. Plus or minus that 1.148. Just like before, you're going to subtract and you're going to add. Okay, we're going to get a confidence interval. So for my lower bound, I got 6.152. For the upper bound, we're just going to add that, and we're going to end up with 8.448. Okay. Last thing we're going to do is we're going to describe what this means. Okay, so describe what it means. Remember, this is a representation of all. Okay, so I'm going to go back up here. My computer is giving me a bit of a fit at this point. So let's go down, see what we can do. There it goes. Maybe it'll reset itself. So what this means, I'll just type it in here somewhere if I can. Oh, this is frustrating. There it is. I'm not sure where the cursor is. It ran away. No, it's doing this thing. All right. It's probably typing somewhere, and I don't know where it's typing. So I'll just describe it. What this means is that we are 95% certain that the true average sleep time of all people is between 6.152 hours and 8.448 hours. I'll type it out on the next video so that way you can see what that actually is. So I would encourage you guys to go to the next problem. What you're going to have to do is you're going to have to do a one-var stat to be able to do the next problem. So you're going to have to enter everything into your calculator under one-var stat. And I'll explain how to do that. But this is what you would do in real life with raw data, is you would first compute X bar, then you would compute S, and then you would go through and find the confidence interval.